Okay, by revolution of the curve about the line theta equal to pi by 2. Simple. So this curve is symmetric about initial line undoubtedly, because if I change theta, so it is r equal to, here r equal to a plus b cos theta. So if I change theta by minus theta, no change. This curve is symmetric about, this is in curve tracing we have discussed about. So curve is symmetric about initial line. This is there. Okay, so again we found out ds upon d theta was, this was what? It was under root a square plus b square plus twice ab cos theta whole power. This is under the square root. ds upon d theta was this value, and therefore required area A is equal to, let me write here, minus pi. This is theta equal to minus pi by 2 plus pi by 2, because this whole arc is revolve about this line. This is minus pi by 2 to plus pi by 2. 2 pi into x into ds. We can write it as twice. This is 2 to the 4 here, 4 pi. Now 0 to pi by 2 limit. So this is twice of this, and minus pi by 2 to plus pi by 2. We can change 0 to, we can write here 0 to pi by 2, and twice multiplied here. And this 2 pi is already there, so this is 4 pi into x into ds d theta into d theta. Now x, we discussed about x is equal to r cos theta. Sorry, x equal to r cos theta. This is the value. We can write here, this is 4 pi 0 to pi by 2. This is r cos theta into ds upon d theta was under the square root a square plus b square plus twice ab cos theta whole power half into d theta. This is the value here. Now let me solve it above. Therefore, this is required solution. This required area. Therefore, required area is equal to, we are solving here. This is nothing but 4 pi, limits 0 to pi by 2. Here r is this value. This is a plus b cos theta into cos theta. This cos theta here. Now second part is within bracket. It is a square plus b square plus twice ab cos theta whole power half into d theta. Now let me further solve it. If I open this by binomial theorem, let me open this by binomial theorem. What? We know that now a square plus b square, let me first solve it separately. Now if I take out of this square root a common, or a square if I take common, so it will be a out. This is 1 plus, this is twice a square. If I divide this, this will be b upon a into cos theta plus b square upon a square whole power 1.2. If I take this one first term and these two as the second term, this is 1 plus a, or if I take a plus b any power, if it is n here. Now we know that what is binomial theorem? By binomial theorem, a plus b whole nth power is a raised power n plus n into a into, a raised power n minus 1 into b plus n into n minus 1 upon factorial 2 into a raised power n minus 2 into b square. But in this case, in place of a, we have a 1. So 1 raised power n is 1, and 1 raised power n minus 1 is 1. So no need of writing 1 here. These two terms will be written as second term. If I open this hole by binomial theorem, let me write here. Then we multiply by these two terms. Then we will integrate them simply. Okay, so here this a square, this value I am calculating. This is a, let me take out, This is now 1 plus twice b upon a into cos theta plus b square upon a square whole power 1.2. If I open this by Barnum theorem, then it will give us first one step, 1 raised power 1.2 is 1 plus then 1.2 n into something, n upon 2, 1.2 into 2 is only b upon a into cos theta, plus this will be, but we will have to multiply b square also by 1.2. This is the first step, 1 plus n into a, n into b or n into b here, because 1 is here a. This is the first step we have taken, plus second step will be, okay, let me take only this one, b upon a, higher power of b upon a, let me neglect them. This only term will be 1.2 n into n minus 1. N minus 1 is 1.2 minus 1, that means minus half. 1 minus 1.2. That means, okay, sorry, 1.2. N is here, 1.2 minus 1 will be minus half here. But this is n into n minus 1. Second step, 1.2 minus 1 is minus half. Okay, divided by factorial 2. That is the first step. Then multiplied by, let me multiply this by this step. This is twice, it will be 4 whole square of this. Also this is 4b square upon a square into cos square theta. Plus neglecting other terms, b square, neglecting here the higher powers of b upon a. The higher powers of b upon a, that are neglected. Only these terms are taken. Okay, up to this term. So what is the further summation of this? Let me further solve it. This is here. This is 1 plus b upon a into cos theta plus 1.2 into b square upon a square minus sign. This will be now minus 1.4, and this 2 is there. So 1.4 and this 4 cancelled out. 4 multiplied, so this 4 is cancelled, but negative sign will be there. It will be 1.2 into b square upon a square into cos square theta. Okay, so these are the steps only. So why this minus sign? Because this is 1.2 into minus 1.2. That is minus 1.4. 1.4 and this 4 multiplied, 4 will cancel out. Only minus 1 upon 2, because factorial 2 is 2. And this is b square upon a square into cos square theta. These 3 steps, sorry, 4, 1, 2, 3, 4. 4 steps we have opened this by Barnum theorem. Now let me multiply by this to this one. Now if I multiply, this is a into, so a we were taking common here. That a we have taken out. Now let me write this here. So what is the final value? Let me write it. Where should I write it? Let me write here. This we have opened. Okay, these 4 steps are there of this. Now cos theta into a plus b cos theta, that is 4 pi into a this we have taken out. Okay, and this is 0 to pi by 2. Now this step is called a cos theta plus b into cos square theta into these values. This is 1 plus b upon a into cos theta plus 1.2 into b square upon a square minus 1.2 into b square upon a square into cos square theta. Okay, these are multiplied and then integrated is d theta after that. So we can obtain the answer then, putting the limit. Now this cos pi by 2 is there. If I multiply by a cos theta to all these terms, what is that value? So first step will be, this is 4 pi a. It's lengthy, no problem, but let me first write by a cos theta. If I multiply each term. This is a cos theta. 1 into a cos theta is a cos theta plus a cancel out. It will be b into cos square theta by a cos theta multiplied to b a upon a into cos theta. A cancel out, b into cos square theta plus this value is 1. If I take common, okay, no need of taking common because let me separate them. This is 1.2 into b square upon a square. A now is cancelled out because this is b square upon a only into cos theta. 1.2 b square upon a square into a cos theta. A cancelled out. So this is 1.2 b square upon a into cos theta. First step we are multiplying into this. This is minus sign. A into cos theta is again 1.2 b square upon a cos q theta. It is now cos q theta. Okay. So that is the value here. Then we have to multiply by b cos square theta to each term, and to be plus b into cos square theta, this first step, plus b square upon a, this one, into cos q theta. Okay, plus sign b into this is 1.2 a square, and in the numerator we have b cube because b into b square into cos square theta. Okay, last term is minus bq again. This is 1.2 bq upon a square into cos 4 theta, cos 8 cos 4 theta. Okay, and this whole d theta. So how many terms are there? 1 2 3 4 and 4 8. 1 2 3 4. Total 8 terms are there. Now each term can be integrated because this 0 to pi by 2 limits. The shortcut formula can be taken here. This is 1 here. Okay, so cos theta can be integrated as sin theta. Sin theta, then 0 to pi. It will be only 1. But let me open this with the help of, okay, cos square theta, cos theta can be integrated simultaneously. This bq. Okay, cos square theta is, there are 3 terms of cos square theta. That's good. Let me write them with like terms. Then we can integrate cos q theta and others. Let me write them in a very peculiar manner. So total answer in that way. First let me write it as a area we are finding out. It is 4 pi into a. So first is 0 to pi by 2. This is a cos theta. Cos theta. Only 2 terms are there. If I take cos theta common, it will be a plus 1.2 into a into b square into cos theta. Can be integrated. Let me write here. This can be integrated here, d theta. Now let me take square, cos square values. So this is b. Okay, cos square, cos, this is b only cos square. This is b again. Okay, twice b it is. So b square, b cos square theta, b cos square theta. Here, the b cos square theta. What I obtain is b cos square theta. It means this is only single term. I have written down this 2 times. Why this has been written 2 times? But this, there are 8 terms only, no problem. So this is b cos theta, twice b, this is step, and this is also the cos square theta. This is plus b cube upon 2a square into cos square theta. Okay, integration sin 0 to pi by 2 into d theta. Now q terms, this is q and this is q here. Only all the square terms we have taken. These, I think, similar terms I have taken. 1, 2, 3. Okay, so there are 4 terms, so it must be there. Alright, so this is now q. So q terms are only 2. Here are the 2 terms here. It is minus b square upon a. This is bq upon a. Okay, no problem. So let me take plus sign first. This one. This is bq upon twice a square minus sign. This is b square upon 2a into cos q theta. Integration sin 0 to pi by 2 into d theta. Now the last term, fourth one. This is only single term here. This is only single term. So that will be, let me write here. So this is nothing but minus sin of integration 0 to pi by 2. This is 1 upon 2. Let me write here minus 1 upon 2 into bq upon a square into cos 4 theta into d theta. Okay, so this can be integrated. Each term can be integrated now by reduction formula. Now this is cos theta, or we can integrate this by sin theta. It will be, then putting 0 to this, only sin theta will be 1. Okay, so this is coming only this value. So if I integrate cos theta as sin theta, then put the limit 0 to pi by 2. Only at pi by 2 the value will be there. But at 0, cos sin 0 is 0. This is only this value. Let me first write. Okay, let me multiply this whole by 4 pi a. First step, this is only a plus 1.2 into b square upon a. We will solve it separately. Now this plus sign, this whole value is twice b plus bq upon twice a square. Now cos square integrated as, how it is integrated? If I put sine over 0 by reduction formula, so sorry, this is 2, it is 1.2 into pi by 2, right? 1.2 into pi by 2 is the value integrated. Now cos q, this is 2 by 3 only. It will be plus bq upon 2a square minus sign, this is b square upon twice a into 2 by 3 with the reduction formula for this. Okay, minus sign, the last one, this is 1.2 bq upon a square. Now cos 4 is, this is 3 by 4. Okay, n minus 1 upon n into 1 upon 2, because it will be then n minus 3 upon n minus 2. This is there into pi by 2. So these are the total steps. Now let me further solve it. That was the final value. This is pi by 4. This is 2 by 3. We have to multiply inside, and this is 3 by 4 to the 8 to the 16 to the 32. So 3 by 32 bq upon 8. This is the whole answer. This is the answer here. Or if I just further solve it, let me solve it here. Therefore, area of this, lemma cone, this lemma cone about the line theta equal to pi by 2 is this much. What is that? 4 pi a in bracket. Okay, so this is a plus, if I take 2 a common, 2 LCM, or 2 LCM, it will be then twice a square plus b square. Let me write like that, twice a square plus b square upon 2a is the first step, plus sign. Again, this is 2a square, also LCM, 2a, and this is 4 here. So 4 to jump, this is pi upon 4, and here it is twice a square if I take LCM. So it will be 4 a square b plus bq divided by twice a square. This value. Okay, and this pi by 4 we have taken this. Now this 2 by 3 is there, plus sign. It is now, if I take 2a square, here also LCM, 2a square, it is 2 by 3 here, 2a square here, then it will be bq minus BQ minus A into B square, BQ minus, this is BQ here, minus AB square upon twice A square, twice A square is also 2 upon 3 is out, minus sign. The last step is BQ pi BQ divided by 3 pi BQ, 3 is also there, divided by A square is there, no problem, but 4 to the 8 to the 16 to the 32 is 32 into A square. This is the whole value in terms of A again. Okay, so this is the answer of question, or second part of question number 10. This is the final answer. Okay, if this is numerical terms, A and B are given, then we can solve it into numerical terms, but this is the final answer. So 4A, for question number 10 complete now. Okay, this is part 1 and part 2. First was about initial line, second is about the line theta equal to pi by 2. About theta equal to pi by 2 is this answer, and previous one, the first part we did in the previous question. Okay, this ends the total questions. These 10 questions I have taken on based on polar equations. Okay, now next topic is double integration, how to find area under double integration. Okay, double integration will take next topic, which ends the complete topics of integral calculus. Okay, that will be my last lecture series. 100th is the last lecture series. If any topic next will be asked by the students, I'll take them later. But next I'll take them next playlist of mine. Okay, the other playlist of mine I'll declare later when I write the volumes here, and after that I'll discuss about. So in this way, this integral calculus is now going to be over. Next lecture is only left. This is the 100th one. So 100th lecture series, which will complete the integral calculus in my perspective. If there is any other topic left over, if the student suggests me, then I'll take that later. But now, for the time, I'm going to end it. But next lecture is also there. After the next lecture means 100th lecture, topic will be over. Okay, then see you in the next lecture series. 100th one. Bye bye.